everyone, welcome back. So this is our last video for this week. So we already learned objective A, draw the electrolytic cells, B, describe the operation of an electrolytic cells, and the factors influence the selective discharge of a species. Okay, now is the last part, which is state Faraday's law of electrolysis. So before we go for Faraday's law, let's do some recap from previous subtopic. So take 2 minutes, try to list down at least 2 difference and 1 similarities between galvanic cell and electrolytic cells. You can pause this video before you go for my answer and check whether your answer is listed or not. Right, comparison of galvanic cells and electrolytic cell. Okay, so the first difference is, first, galvanic cells is actually chemical energy converted into electrical energy. So chemical energy that come from the reduction oxidation that happen due to difference of reduction potential drive the movement of electrons and produce electrical energy that can be detected by voltmeter. Okay, while electrolytic cell is actually electrical energy converted into chemical energy. So energy from battery, okay, drive the movement of electron and force the oxidation and reduction to happen at electrodes. Okay, next difference is anode is negatively charged and cathode is positively charged at galvanic cell. Okay, while anode is positively charged and cathode is negatively charged at electrolytic cell. Okay, so in galvanic cell is a spontaneous redox reaction, okay, while electrolytic cell is non-spontaneous redox reaction. Right, so next is similarities between these two electrochemical cell. Okay, first, oxidation always at anode and reduction always at cathode. So red cat is applicable for both galvanic cell and electrolytic cell. Second, both cells consist of electrodes and electrolytes. Okay, so how about your answer? So hopefully, so this comparison will help you to understand better for these two different electrochemical cell. So let's go for the last part of this topic, Faraday's law of electrolysis. Okay, so Michel Faraday, so this scientist Michel Faraday found that during electrolysis, the quantities of substance liberated at electrodes depends on the following factors. So what are those factors? First, the quantity of the current passed, okay, time duration of passing the current at uniform rate, and the last factor is charge on the ions being deposited. So the statements of Faraday's law is the quantity of the substance formed at an electrode is directly proportional to the quantity of electric charge that has flowed through the circuit. Okay, so M, mass of the substance discharged, is directly proportional to the Q, electric charge in coulomb. Right, so how to calculate Q? Q is equal with IT. Okay, so what is I? Current in amperes. T is time in second. Okay, so Faraday constant is charge on 1 mole of electron. Okay, so 1 Faraday consists of 96500 coulomb. Okay, for example, copper ion accept electron to produce copper solid. So this solid will be deposited at cathode electron. So theoretically, copper ion requires 2 mole of electrons to form 1 mole of copper solid, or 63.5 gram copper. Okay, so if we convert electron to Faraday, okay, so copper ion requires 2 Faraday to form 1 mole of copper. Okay, then we convert Faraday with Faraday constant, so we times with Faraday constant. Okay, copper ion requires 2 times 96500 coulomb to form 1 mole of copper solid. Okay, therefore if only 96500 coulomb or 1 Faraday pass through the electrolytic cell, okay, the mass of copper formed is 31.75 gram, or actually we divide this mole of this mass of copper divide with 2. Okay, so the higher the quantity of electric flow in the circuit, the mass of copper formed will be increased. So that's all for chapter 3. Thank you for watching.